Alright, moving on to the next part. Starts at 1, timed by 5 every time. So you gotta do 125 times 5. I'll give you 625. And then you gotta take that and times it by 5, which will give you 3,125. And then you gotta times it by 5 again to get 15,625. And we have a common ratio of 5, so this is gonna be a geometric type sequence. And now we're going to do the recursive function. Remember, it's geometric, so you got a little bit of a different form. But remember, a sub n equals a sub n minus 1 times 5. And I could just put the 5 in front if I want. And that's the kind that shows up on your paper, your notes. A sub 1 is your first number, 1. And now I want the explicit function. I'm going to do f of n equals my initial value times my common ratio to the n minus 1 power, and that's done. Now we need to get a sub 9. You take 9 and you put it in for n right there. And so we got to do 9 minus 1, which is 8. 5 to the 8th power. And you just kind of plug that in a calculator and it will get it for you. And that is 390,625. And that one, yeah, should be pretty much done. Moving on to number 5, I notice I have a little pattern. Whoops. I have a pattern here of dividing by -3. And so, if you have a fraction here and you're dividing by something like -3, you just keep the top the same and multiply the bottom by -3. So we get -9, 4 over 27. Oh, that's hideous too. 27, and then 4 over -81. And those are going to be my next terms as a common ratio of -1/3, because you're dividing by -3 every time, so you'd be multiplying by -1/3. I need to fix that real quick. That 3 is not readable. Alright, so now we got that. This one is going to be a geometric type because, well, we're multiplying every time. And I'm going to write the recursive formula right here. A sub n equals a sub n minus 1 times by -1/3. And then a sub 1 equals -36, my start value there. The explicit function is going to look a lot like the last one. Initial value times common ratio to the n minus 1 power. And now that you got that, getting a sub 9 is pretty quick, because you take 9 and you put it in for n and do some calculations. But a little hint here. If you're trying to do like a fraction like this in your calculator, and then times it by the 36, it can be a little bit difficult trying to get the fraction right. And your calculator may or may not be able to convert it to a fraction. It just depends on what type you have. But I also noticed that I'm already at the 7th term right there. And so if I just times the bottom by -3 and then times it by -3 again, I'll have my 9th term. And so I'm going to do that. I'm going to do 4 over -81 times -1/3, and then I'm going to times it by -1/3 again. And so I'm going to do 81 times 3 times 3. Oh man. 81 times 3 times 3. I'm going to get 4 over -4 over 729. And there we go, that's going to be my 9th term. Moving on to number 5. Romo makes $12 first hour, $17 next hour, $22 in the third hour, and so on. Well, this is a pattern just 12, 17, 22, which has a common difference of $5. My initial value is 12. And so if I write a little function here that describes what this number in the sequence is, if you know which one you're looking for, is going to be common difference times n minus 1 plus initial value. And I do start counting my first term in the sequence with the first hour work, so I will plug in 50 here to get my 50th, how much work he earns for his 5th hour work, right in there. So I gotta do 50 minus 1, times it by 5, add 12, go gadget calculator. Let's say I do 49 times 5, add 12, oops, run it. 49 times 5, add 12, and that will give you a grand total of, sorry, 257. Ta-da! And that's a lot of money. That's dollars, man.